All right, so let's look at the R.A.T.E.Y Part 2 homeworks where we focus on some top heavy situations. All right, number one, it's not a top heavy situation, so let's just kind of like ease into the process, shall we? All right, so the first thing I noticed, right, because the rule is, you know, different from part one, is that now we want to factor before we do anything. That's the best practice if it can be factored, right? You know, the factored version we can do more things with. So I recognize that there's a difference of squares in the bottom, right? X plus 1, x minus 1. All right, so first step, we set the top equal to 0. So x equals 0 is our x-intercept. Second step, vertical asymptotes, we set the bottom equal to 0. So this means x is equal to -1 and +1. So there are vertical asymptotes at negative and +1. Then we see, are there any square factors in the top or bottom, in the numerator or denominator? And no. And neither. So this tells us that the branches are going to go away from each other around the asymptotes, the vertical asymptotes. All right, in behaviors, what horizontal asymptote will it tend towards? Well, this is bottom heavy. So y equals 0. And then the y-intercept, when x is equal to 0, we're going to get 0 over 0 minus 1, which is basically 0. Y equals 0. And we already noticed that. And right away we see that the horizontal asymptote goes through the x and the y-intercept. So we know that this is possible around the origin, right? Because the horizontal asymptote only tells us what the end behaviors, the end of the branches are doing, not close to the origin. Okay. So looking at the first branch, the obvious one, right? Well, we know it has to go through here. But the question is, does it go this way or does it go this way? That's really the question. So we have to pick. All right, for a second, it felt like we had done this already. So we pick a number left or right of 0. So I'm going to pick 1/2. So this is going to be right. So when x is 1/2, we're going to get 2 times 1/2 over 1/2 squared minus 1. All right. This is going to equal. So 2 times 1/2 is 1. That's nice. Over 1/4 minus 1, which is basically 1 over -3/4. We have a compound fraction, or when you divide by a fraction, that's the same as multiplying by the reciprocal. So we keep the top, change the multiplication, and multiply by the reciprocal. We flip it. So -4/3. So when x is 1/2, y is -4/3. So x is 1/2. Y is going to be a negative 1 1/3. So here. So right away that tells us exactly which way this is going to go. So it's going to go down towards this asymptote, and then because of symmetry, it's going to come up. All right. And again, because we answered no to the bottom part, that means that the branches are going to go in opposite directions around that vertical asymptote, around all vertical asymptotes, and then out towards the horizontal asymptote. That's how it looks. Right. Usually when you have an x squared, they look crazy. So, all right, here's our first top heavy problem. All right, so first thing I'm gonna do is factor the top. That's a difference of squares. X minus 1, x plus 1, x minus 1 in the bottom. All right, so the first thing I notice is that x minus 1 is going to cancel. So this tells me, right, remember that holes cancel, right? Holes cancel. So there's a hole at x equals positive 1. So at x equals 1, there's a hole. So really, the new function is y equals x plus 1. Now, we know that that's a linear line, right, that goes through 1, positive 1, and has a slope of 1, up 1 over 1. And we know that there's a hole at x equals 1. And I think that really does it, right? Like there's really no more to discuss. Okay. So here we're going to factor the bottom, x plus 1, x minus 1, setting the top equal to 0. Well, first off, nothing cancels, so that's fine. Setting the top equal to 0, we see that x has to equal 0. So the x-intercept is at x equals 0. Setting the bottom equal to 0, x has to equal -1 and +1. So there's vertical asymptotes at -1 and +1. Then we say, okay, is there a square factor in the numerator? Yes, there is. So that means, so let's pause for a second. So this means that at the x value in the numerator, so where it's equal to 0, the x-intercept, right, is going to bounce. And is there a square factor in the denominator? No, there's no squared factor in the denominator. So that means that the branches are going to go opposite of each other. All right. The horizontal asymptote that the end behavior is going to tend towards, we look at the degree in the numerator, degree in the denominator, and we see that they're balanced, right? 2 square on top, 2 on top, 2 on bottom. So now, because it's balanced, we have to look at the coefficients, the ratio of the coefficients. So 3/1. So that means y is equal to 3. That is where the horizontal asymptote is going to be. All right, and the y-intercept, is going to be when x is equal to 0. So again, y is equal to 0. Okay. So looking at this, the first one's always obvious. Given the checklist and everything that we know that the x-intercept is at the origin. The y-intercept is at the origin. We know that it's going to bounce at the origin. We know it has to go away from the horizontal asymptote and it has to go towards the vertical asymptotes. Okay. We also know that the branches have to go opposite of each other around the vertical asymptotes. Okay. All right. Number 4. I see that the top is a difference of squares. So factoring the top, we get x minus 3, x plus 3. Denominator, x squared plus 2x squared plus 1. Nothing we can do. All right, setting the top equal to 0. X minus 3, x plus 3. This is x is equal to 3 and -3. These are the x-intercepts. So it's going to cross at 3 and -3. All right, looking for the vertical asymptote, setting the bottom equal to 0. We're going to get when you take a square root of a negative number, this is not a real number. So there are no vertical asymptotes. Okay, so this is looking kind of crazy already. Is there a square factor in the top or the bottom? Nope. Nope. Okay. We look at the end behavior. We take the degree in the numerator and the degree in the denominator. So both are 2. So it's balanced. So now we take the ratio of the coefficients. So y equals 1/2. All right, and we look at the y-intercept. Is there a y-intercept? So when x is equal to 0, we get 0 minus 9 over 0 plus 1, which is negative 9. Y equals negative 9. Okay, so let's see. What do we have here? Well, I know that it has to cross the y-axis at 9, but it also has to cross the x-axis at 3s, negative 3 and positive 3. And it has to tend towards the horizontal asymptote. So we're going to get something that'll look like this. It's kind of crazy. Okay. All right. Number 5. The top can't be factored. However, the bottom can be factored. I can factor out an x, and x minus 3 is left over. Okay. Looking at, and nothing can cancel. All right, looking at the numerator, setting it equal to 0, the x-intercept is going to be at positive 4. Setting the denominator equal to 0. So we're going to get either x is equal to 0 or x is equal to positive 3. Right, because those are the 2 values that'll make this 0. So the vertical asymptotes are going to be at x equals 0 and x equals 3. All right, is there any square factors in the numerator? No. Denominator? No. The vertical or the horizontal asymptote that the end will tend towards. So we compare the degree in the numerator to the degree in the denominator, and we see that this is bottom heavy. So y equals 0. All right, and we just want to note that, look, the horizontal asymptote goes through the x-intercept. So we know that that's okay. And is there going to be a y-intercept when x is 0? So negative. So when x is 0, we're going to get 0 minus 0. So it's undefined when x is 0. So no y-intercept. Which makes sense because there's a vertical asymptote through x equals 0, which is basically the y-axis. So, all right. So let's see. The only thing we can do, right, because it's not obvious, but we definitely want to start at the x-intercept. So we all want to pick a number, left or right of 4. So I'm going to go right of 4, which would be 5. So when x is 5, y is going to be 5 minus 4 over 5 times 5 minus 3, which is basically 5 minus 4 is 1. 5 minus 3 is 2. 2 times 5 is 10. So the most important part is that it's positive, right? That the y value is going to be positive. So it's going to be a tenth. So this means that it's going to come up from the vertical asymptote through the x-axis, through the 1/10, and probably back down towards the asymptote. Actually, it will go because if you think about it, 6, right? 6 is going to make the denominator even bigger. And when a denominator gets bigger, the value will actually get smaller, right? If we plug in 6, this would be 6 minus 4, 6 times 6 minus 3. This would be 2 over 6 minus 3 is 3. 3 times 6 is 18, which is 1/9. That just proves me wrong. The bottom got smaller, so it gets slightly bigger. Interesting. Wonder how high up does it go? Right, it's not going to go up much higher. At some point, though, it's definitely going to come back down and start tending towards the vertical or the horizontal asymptote for sure. Okay, so then all right, and then again, because we answered no to the bottom, that the branches have to go away from each other at the asymptotes. And it can't cross either at the horizontal asymptote. So if we wanted, which we can do this real quick, if we pick, let's say, 1, 2, 3. So if I pick 1, right, let's just let x equal 1. What's y have to be? So y is going to be 1 minus 4 over 1 minus 3. So this is going to be negative 3 over negative 2, which is basically positive 3/2. So 1.5. So at 1, it's 1.5. What's it going to be at 2? So we have 2 minus 4 over 2 squared, which is 4, minus 3 times 2, which is 6. So this is going to be negative 2. 4 minus 6 is also negative 2. So this is positive 1. So when x is 2, so the graph is going to look something like this. And the last branch has to go away from the vertical asymptote, or it has to go away from the other branch along that vertical asymptote. And it doesn't cross the horizontal asymptote, right? Because there's only one x intercept. All right, number 6. Factor in the top, we get x minus 6, x plus 6. It's a difference of squares. X plus 6 in the bottom. Right away, I see that the x plus 6 cancels. So that means there's a hole at x equals negative 6. Somewhere, however this looks, there's going to be a hole at x equals negative 6. Okay, so that function is going to look like y equals x minus 6. So that's kind of nice. It's just a linear graph. So 1, 2, 3, 4, 5, 6. And the slope is 1, 1, up 1 over 1. So we're going to get 1, 2, 3, 4, 5, 6. So the hole is going to be on the x-axis. Or not on the x-axis, because it's at x equals negative 6. So 1, 2, 3, 4, 5, 6. So negative 6. So we'll extend this out. So somewhere here. So at x equals negative 6, there's a hole. And that's it. But there's no vertical asymptotes. There's no horizontal asymptotes. There's no end behavior, right? It's just a linear line with a hole at 6, negative 6. X equals negative 6. All right. Quadratic on the bottom. So this is going to be two numbers that multiply to make 6 that add up to 1, 2, and 3. They both have to be negative. No, they don't have to be negative. One of them has to be negative. So which one? Well, it's going to be the big one has to be negative, right? Because negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. All right, setting the top equal to 0. Can't do it, so there's no x-intercept. Setting the bottom equal to 0. X equals negative 2 and positive 3. So that's where my vertical asymptotes are going to be. So negative 2. Positive 3. Is there any square factors in the top and bottom? No and no. In behavior, horizontal asymptote. This is definitely bottom heavy. So y equals 0. And then the y-intercept is when x is equal to 0, we're going to get 8 over 0 minus 6. 8 over negative 6. So what is that? That's 1 1/3. Negative 1 1/3. Okay, so putting it all together, we're going to get, it has to cross the y-axis, come down towards the asymptotes. And then because of the no, we know that the branches are going to go opposite of each other at the vertical asymptotes. Number 8. Factor in the bottom. X plus 3, x minus 3. Top, can't factor it, 2x squared. Okay. Setting the top equal to 0. X has to be 0. Setting the bottom equal to 0. So, well, first off, the x-intercept, right, is at x equals 0. Setting the bottom equal to 0. X equals negative 3 and positive 3. So vertical asymptotes at negative 3, positive 3. Are there any square factors in the top and bottom? So top, yes, there is. So that means at that x-intercept value that's in the top, that's where the graph is going to bounce. On the bottom, there's not. So that means that at the vertical asymptotes, the graphs are going to go in opposite directions. Horizontal asymptote that the end is going to tend towards. We look at the degree in the numerator, degree in the denominator, and we see that it's balanced. So we take the ratio of the coefficients. So y is equal to 2, right? 2 over 1. All right, and then the y-intercept is when x is equal to 0. We get 0 over 0 minus 9, which is 0. So y is equal to 0. And that's what we see. So the graph is going to bounce off of the x-axis, go towards the vertical asymptotes, and then the branch is going to go in opposite directions at the vertical asymptotes. Right, one side goes up, the other side goes down. All right, number 9. Top can't be factored. The bottom is x minus 3, x plus 3. Nothing can cancel. The top can be set equal to 0. So there's no x-intercepts. Vertical asymptotes are going to be when the bottom is equal to 0. So x equals 3 and negative 3. All right, looking at, are there any square factors? In the top, no. Bottom, no. The end behavior, we compare the degree in the numerator to the degree in the denominator, and this is bottom heavy. So it's going to be y equals 0. All right, and it crosses the y-axis when x is 0. So negative 10 over 0 minus 3 times 0 plus 3. So this is going to be negative 3 times 3, which is negative 9. So negative 10 over negative 9, which is positive 10 ninths. So it's, still it's a little bit, it's a ninth bigger than 1. Right? 1 and 1 ninth. Positive 1 and 1 ninth. Okay. So now, if we want, I mean, I feel it's pretty obvious, but let's say it's it's not obvious. Like if you're not keen to the obvious, then if I pick something left and right of this y axis or y intercept, so let's do 1. So when x is equal to 1, we get negative 10 over 1 minus 3, which is negative 2, times 1 plus 3, which is 4. And this is going to be negative 10 over negative 8, which is basically positive 5/4, which is a 1.25. Is 5/4 bigger or smaller than 10 ninths? What do you think? Which one do you think is bigger? I feel like it's like 1.1111 something. But let's just see. Let's just compare. I don't have a calculator handy. So versus 5/4. So 9, 4. This is going to be 40 over 36. This is going to be 45 over 36. So yeah, 5/4 is bigger. It's going to be higher up. All right, so basically what I did was I got a common denominator. Okay, so that tells us that it's going to go up. That's all that tells us, both sides. Then, because it's no, right, the branches must be opposite of each other at the vertical asymptotes. Okay, there it is. Two more. Let's go. All right. The top can't be factored. Neither can the bottom. Right? You can't factor the top or the bottom. Well, into nice whole numbers. So setting the top equal to 0. To find the x-intercepts, this is going to come out to x squared is equal to negative 3. Again, we can't take the square root of a negative number, so there's no x-intercept. Setting the bottom equal to 0, x has to be 0. So this is going to be a vertical asymptote through x equals 0. All right. So here's kind of a weird one. Is there a square factor in the top or the bottom? So top, no. Is there a square factor in the bottom? No, because there's a cubed factor in the bottom. There's not a squared, right? It is not. So in behavior, degree in the top, degree in the bottom. This is definitely bottom heavy. So y equals 0 is the horizontal asymptote that the ends are going to tend towards. And the y-intercept is when x is 0. This will give us undefined because there'll be a 0 in the bottom. So there's no y-intercept. So no x-intercept, no y-intercept. So this is basically What do you think? I feel like it's going to be like this. But let's see. If I let x equal 1, I'm going to get 1 plus 3 is 4. 2 times 1 is 2. So positive 2. So when x is 1, y is 2, which proves my suspicions. So the graph is going to look like this. And then they have to go away from each other because it's no, right? So okay. Last one. And it's an easy one. Okay, can be factored. Top can be 0. So no x-intercept. Bottom, there's no vertical asymptotes, right? Because x squared plus 1 equals 0. Never. There's no square factors in top or bottom. The end behavior is going to be y equals 0 because it's bottom heavy. And the y-axis is when x is 0. So this is going to be when y is 6. Right, 6 over 1. Okay, so if you want to get an accurate location of the little mound, so if I let x equal 1 and negative 1, well, it's symmetrical. So if I let x equal 1, 6 over 2, which is basically 3. So when x is 1, y is 3. How about 2? Just curious. So this is going to be 6 over 2 squared is 4, plus 1 is 5. So 1 and a fifth, so 1.2. So when x is 2, it's going to be 1.2. All right. So we have an idea of what this is going to look like. Okay. There it is. Hope it helps you out.